Hello friends and welcome to Chat from the Engineering Desk. I found another item in the dumpster this week, and it is this here Bosch heat producing device. Rated there at 1800 watts at 220 volts. This is for use on 50 Hz 220 volts. Somebody removed the power source from it and put it in file 13. So let's take it apart and learn how they work. So what we need here is some flips, screwdriver bits. I hope that fits. Yes, it does. So, how's your week been? How's the sort of rollout to the end of 2023 been for you guys? Been doing anything interesting? What's been good? Certainly the mood is more festive this time of the year. Things become relaxed. People start thinking of going on vacation and so on. It's also a time of the year when we do a lot of project work. Got customers who upgrading equipment, and during the December shutdown period, that's when they do it. Big projects happen. So December is actually a busy time for us. So, busy getting here with these screws. Two more to go. Then we'll find out what happened here. What has gone wrong? Right. That works. And get a bigger, longer screwdriver. And it's out. There's your clamshell. A little bit of sparkly stuff going on there. This is actually the first time I've been into one of these. Let's set that aside. So what do we have? More screws. Let's remove them. See what's going on in here. There is the selector for the airflow and heat. So let's do some basic electrical tests. See if there's any clues. in that device. And that seems to only be doing something 300 ohms when we get to the top here. That's the minimum setting. So that's low heat, medium heat, and high heat. We don't have continuity, which is obviously an issue when you're trying to get some shrink sleeving hot. That's not going to work. Okay, keep going. Let's take that out. There's a long screw, right? Ah, the lid is from the mica. So there's the safety device, prevent overheating. And this is very much a standard fan, which has got a DC motor on it, permanent magnets, hence a rectifier on the back. So if we connect that to a power supply, that's producing airflow. It's a drawing, half an amp. So that's the blower, which moves the air through the heater. I had it up at 24 volts there. So let's go further into this. It's interesting that it's a centrifugal impeller, not an axial type like you find in hair dryers. They've got higher air pressures but lower volumes. So the idea of these things is to produce pretty hot air. that ring? Whatever. Oh yes, there's a insulated support, so that's in a groove. It's just got these 3 contact points for electric thermal insulation. Ah, here we go. So that's what that looks like. The tube with the guard on the end with mica in it. Yeah, so that's what this looks like. There's a heater with some ceramic supports for the wires. Oh, there's your problem. That's where it's failed. Bing. I think this thing got dropped. And there's your various taps of the heater. So it's like that. So what they do is some current for the motor, for the blower motor, gets tapped off this heating element. That's where the power for that is from. And obviously, this being an AC appliance, got this rectifier on the back with some suppression capacitors, and that runs the DC blower motor. That might actually be inductors. But anyhow, there's your suppression capacitor. So that's what that's all about. This has got more filtering over here. And that just slipped onto here. And it's got a little foam thing. And here, oh, so that's how they do it. So the other run halfway through the element of the diode, or they run both cycles through the element for full temperature. So that's how half and full heat is controlled by virtue of that diode at the end. Very interesting. And that was that. And that's pressed on. So that let's do that like that. Air goes in there, out there. So that spins it. that way. There's those curved vanes in there for the turbine. They're simple things. If you were to open a head dryer, it'd be very similar inside. Been done like this for a long time. It works. It's a pretty standard sort of mature technology. Oh, there's screws holding that onto there, yeah. Let's see, no, that's not coming off. I think we'll leave it at that. So now we know why it was in there. The heating element went kapui. The rest of it's all in working order. These things are throwaway items when it goes wrong. There's no chance of doing anything about this problem over here where it's failed. So this can go to recycling, and then we'll move on to more things. Ladies and gentlemen, thanks for being here. Have yourselves a wonderful day further. Take care, and I'll see you for more next time. Cheers.